Bismillahirrahmanirrahim. Assalamu alaikum. Myself Abdiya and I am from BSBT. My today's topic of presentation is dichloroacetic acid. And here are the contents. First of all, we'll talk about introduction, that what is dichloroacetic acid, its structure and its formula. Its preparation, the different methods we can use to prepare dichloroacetic acid in laboratory and even on the commercial scale. Its occurrence, how does it occur in nature, in which forms, physical properties, chemical properties, its application, its uses in different fields. What is dichloroacetic acid? It is an organochlorine compound comprising acetic acid and two chlorine substituents. Initially, acetic acid has 3 hydrogen atoms with its methyl group. 2 of 3 hydrogen atoms get replaced with chlorine atoms and we get dichloroacetic acid. Di means 2. So dichloroacetic acid has 2 chlorine atoms with methyl group of acetic acid. It is an analog of acetic acid, meaning it has similar structure as that of acetic acid. And here is its molecular formula. On the left side is the two-dimensional structure and on the right side is the three-dimensional structure of dichloroacetic acid. Green balls show chlorine atoms, white balls show hydrogen atoms, black balls are for carbon and red balls are for oxygen atoms. Preparation. The different methods, the different reactions we can use to get dichloroacetic acid. Dichloroacetic acid was first synthesized by the chlorination of monochloroacetic acid in the presence of acetyl chloride. In the reaction given below, the first reactant is acetyl chloride and the second reactant is monochloroacetic acid. They both react in the presence of HCl to give dichloroacetic acid. The second is by hydrolysis of dichloroacetyl chloride. It is the two-step process. In the first step, dichloroacetyl chloride is converted into monochloroacetic acid, and in the second step, that monochloroacetic acid is converted into dichloroacetic acid. And here are some more methods by hydrolysis of pentachloroethane. This section takes place in the presence of H2SO4, meaning hydrolysis of pentachloroethane in the acidic medium gives dichloroacetic acid. By oxidation of dichloroacetone, the ketonic group oxidizes to carboxylic group. So, oxidation of dichloroacetone will give dichloroacetic acid. It occurs in the presence of nitric acid and oxygen. By dechlorination of trichloroacetic acid. Trichloroacetic acid has 3 chlorine atoms. By removing one chlorine atom, this process is called dechlorination. We can get dichloroacetic acid. It is a catalytic reaction and catalyst used is palladium. We can also get dichloroacetic acid by the direct chlorination of acetic acid in the presence of iodine. Occurrence. Commercially, dichloroacetic acid is present with 98% purity. Other 2% contain monochloroacetic acid, trichloroacetic acid, and water. And there are different companies in the world that produce dichloroacetic acid, for example, China, Japan, USA, and Mexico. Naturally, it is present in seaweed named Asparagopsis taxiformis. It is also present in drinking water in traces in very less amount. As you can see in the table, for example, Australia. In Australia, it is present in 1 to 46 microgram per liter in drinking water, and in China and in Greece. You can also see. Properties. It is present in 2 crystalline forms. It is colorless liquid, has a very pungent odor, boiling point 193 to 194 degrees C. As I told earlier, it has 2 crystal forms. One crystal shows melting point of 9.7 degrees C and other crystal has melting point of -4 degrees C. And of density, its density related to water is 1.563 at 20 degrees C. As it is acid, so we should talk about its pKa value. Its pKa value is 1.35, which means it is very strong organic acid. It may be corrosive, it gives off acidic vapors, and can be extremely destructive to human tissues. Solubility. It is soluble in organic solvents like acetone. It is slightly soluble in polar solvent like water and carbon tetrachloride. Decomposition. Its decomposition is so hazardous. It gives carbon oxides, hydrogen chloride gas, fumes of chloride under fire conditions. Applications. It is used in different industries for different purposes. In First of all, its industrial uses. In different industries, it is used to manufacture different beneficial compounds, different important chemicals, for example, glyoxylic acid. It is also used as an analytical reagent in the manufacturing of fiber of polymers. Laboratory uses. In laboratory, it is used as a laboratory reagent. It has ability to precipitate out macromolecules, for example protein, from the solution, so we can separate protein from other macromolecule by using dichloroacetic acid. Therapeutic uses. Dichloroacetic acid is also used for healing purposes. For example, lactic acidosis. Lactic acidosis is a medical condition in which mitochondria is unable to perform its function properly, and due to which lactic acid starts accumulating in the body. It is a congenital disease, a genetic disease, so we use dichloroacetic acid for it, as it cannot be treated 100% but to some extent. It is also used as an investigational drug for diabetes and for tumor growth. It is also proposed for use in targeted therapy against cancer, but due to its side effects, it is not common in use as a therapeutic agent. It can cause DNA mutations, DNA aberrations, and can be harmful. Medical uses. It is also used in medical field as a cauterizing agent. To cauterize means to stop bleeding by coagulating cellular proteins. It also means to stop it also means to close wounds. It is also used as a disinfectant. Cosmetic uses. It has also its application in cosmetic treatments, for example, tattoo removal. Agrochemical uses. It is used in agriculture for the preparation of iron chelates. Iron is a nutrient that is required by the plants. Iron chelates are the iron chelates. To make iron readily available for plants, chelates is used to keep iron in the form that plants can use. Chelates prevent iron from oxidation, from leaching out of the soil. So in this process, we use dichloroacetic acid. It is also known as environmental transformation product of dichlorovos. Dichlorovos are used for insect control, and on exposing to environment, they are converted into dichloroacetic acid. Dichloroacetic acid has also its application as a fungicidal and a virucidal. So that's all about dichloroacetic acid, and here are the references from which I collected my presentation material. That's all. Thank you.